Okay, this is part 5. We will continue where we stopped last time, and that's question 9. Suppose you take a sample of Nova Scotian, ask them to remove all the cautions to see how much coin or whatever amount of money they have, and the sample they pick 10 people, and they give you the average, the sample mean, that's X bar, so they give you X bar, and that's $3.67, and they give you the sample standard deviation S, and that's 175, and that's for a sample of 10. They want 95% confidence true mean. When you see a question, this is the key word, confidence interval, true mean, then you'll use this formula. X bar plus or minus T star S over square root of F. But to be able to do this, you need to figure out what T star is. Degrees of freedom for one sample would be n minus 1, and they tell you that it's 95%. So you go to your T table, you go to the T table, degrees freedom, 9 with 95, and the number is 2.62. 2.262, yeah. Then you put everything together. The average, 3.67. Your T number is 2.262. The standard deviation is 175, and it's the square root of n. So you bring the first number, you just write the first number. You only calculate what comes after the plus minus. See what this number is. And this number is 12518. You open brackets, and once again you minus them, you add them. So 367 minus 1.2518 takes you down to 24182, and when you add them, takes you up to 49218. Now we go, we see what, this is only question 9a. Question 9b, would 95% confidence interval be wider or narrower? Now remember, this is 95% confidence interval. They want you to go to 90%. Would it be wider or narrower? Anytime when the confidence level, when it becomes less, that means it's becoming narrower. So when it becomes less, it's becoming narrower. So the higher, remember, higher the level, the wider it is. Higher level, wider it is. This is similar to a previous question. Remember, if you do this 20 times, if you perform this confidence interval 20 times, how many of those times you think it will include the true value? Remember with this, and I wrote down containing true value or true mean or true proportion. So if you do it 20 times, and every time you do it at 95%, so 95 times 20, there will be 19 times. This will provide the true value. Now the deep question is to perform a hypothesis to the same thing, to the same problem. Now, this they claim that the true amount of loose change held in Canadian living room furniture is 2.5. The household against the alternative that it's larger. So the alternative is larger than 2.5. Hypothesis H0. It's one average. It's one average. You say mu $2.50 compared to alternative 2.50. They want you to say mu because it's one average system. Now, this indicates that you have one tail. Again, more is one tail, less is one tail, not equal. That's the only time that it's two tail. The t statistic for this type, when it's one, again, it's one average. The t statistic would be x bar minus mu s over square root of m. X bar is the one given, mu in the hypothesis, s given, and it's the square root of 10. So you do the calculation, and this gives you 2.1142. So that's your t observed, t statistics. What's the distribution p-value? So you wanted to find the p-value, and what's the conclusion? Okay. How do we find the p-value when it's t? P-value, right away you need to do your DTT. Degrees of freedom. We did this earlier. It's sample minus 1, 10 minus 1, 9. And the test, we found it to be 21142. And the tail, it's one tail system. So you go to your t-table. And when you go to the t-table, you go to the line for degree freedom 9. And you look for this number, 2.11. In degree freedom 9, you'll see that your number 211 is between 1833 and 2.262. So it's somewhere between these two. So you go up and you see what the two percentages are for one tail. So the one tail percentage, you're between, p-value is somewhere between 5% and 2.5. So now you go back to your question. If that's your p-value, what's the conclusion? Now, once I know that this is my p-value, remember, they give you, first of all, alpha of 5%. P-value, less than or equal alpha, reject H0, conclude HA. Your p-value is somewhere between 2.5 and 5%. Say p-value is 3%. Is 3 less than 5? Definitely. So your p-value is less than or equal alpha of 5%. Less, then you say reject H0, conclude HA. We have significant results. Now, if you conclude HA, then you say yes, true mean of loose change is more than 2.5. We are concluding HA that says that the average loose money is $2.50. Okay. After this, in the sample, there are some multiple choice. Actually, two of them are in the last assignment, or actually 3 of them in the last assignment. One of them is a calculation, so just plugging numbers into formula, or basically dividing these two, so there's nothing really special about this. Pretty much the only thing that I want to talk about is question 14, because there is a possibility that you might see something like this. So in question 14, they give you 2 pictures. In the first one, you see dotted lines like this. And in the other one, you see going up, going down like this. Now, I'm gonna add maybe a couple more, or maybe 3 more. I'll do 3 more. I'll do one where it's like this. I'll do one going down like this. And I do one like this. And the question for all of them, let's say this is graph A, B, so these are the only 2 given, but I thought that I'll give you more. And they tell you, can you determine the R value, and is it good or bad? But we don't say good, we say appropriate. For all of them. And the selections you're given, 0.7, point negative, 0.002, and 9.8. And let's consider this for all of them. Now, if you look at this one, you'll see, try to imagine a straight line, close to all the points. A straight line that's close to all the points would be a line like this, going down. So once I know it's going down, so I know that my R would be negative. So I'm between this one and this one. If you think that the points are very close to each other, similar to this one is going down, but they're very close, so a straight line would be probably perfect here. All the points would be very, very close to the straight line. So this one is a very good negative correlation. So this one would be the minus 0.98. This one would be negative, but somehow good. But still appropriate. Anytime your R value between 0.6 above or 0.6 more, we consider this to be appropriate. Sometimes even they go down to 0.5 and say 0.5 more is also appropriate. Now, if you look at this, this is positive correlation. The points are somehow close to each other, so we go, it's like 0.7. Now this one, if you look at this one, it's going down, then going up. We consider this that they cancel each other. So they're going down, going up. That means that R is very, very close to 0. And the closest of them to 0 would be 0.02. And that would be not appropriate in this case. When you have them like on a horizontal line like this, that means that there is no relation. There is no R, no correlation in this case. So obviously no correlation would be not appropriate. So there will be one more video explaining the last question, the regression, which is very, very similar to the one we did in the last assignment. But I'll write down the formulas and we'll do this in last part.